and welcome everyone. Before we get started, we wanted to announce some quick housekeeping messages. For all of our virtual presentations, we provide both ADA compliant live captioning and ASL interpretation. To activate the ADA compliant live captioning, you'll look on the bottom of your screen, find the button that says closed caption, and then click the upward facing arrow. And then you can select show subtitle. To see ASL interpretation, at the bottom of your screen, click the button that says interpretation, and then select American Sign Language. If you need any more time to do that, please just refer to the text in the chat from our tech host, where you can follow the steps that I just mentioned. Throughout this talk, you can type into the Q&A if you have any questions at all. We will monitor your questions and we will ask them to the presenter at the end of this presentation during the Q&A portion. So we're officially started now. Welcome everyone. My name is Jesse. I'm part of the Voyageurs Conservancy. And we want to kind of just introduce you to Boreal Stargazing Week because that's what this presentation is part of. Boreal Stargazing Week is a celebration of Minnesota's dark sky parks, Voyageurs National Park, and the Boundary Waters Canoe Area Wilderness. Many partners have come together to host a week of free activities across Minnesota, both in person and virtually. Boreal Stargazing Week programs are brought to you by Voyageurs Conservancy, Friends of the Boundary Waters Wilderness, Starry Skies North, Voyageurs National Park, Superior National Forest, Expeditions and Education, the Bell Museum, Wood Lake Nature Center, and NASA's Goddard Space Flight. So, Boreal Stargazing Week is about appreciation of dark skies and capturing that tremendous wave of awe that you feel when you are underneath a blanket of stars. Dark sky parks like Voyageurs National Park and Boundary Waters are places with amazing dark skies that provide us that environment to look up and wonder. But the next time you're looking out into the depths of the vastness of space and wondering about what is out there, know that there are people who work to discover what is out there. That is, there are dedicated teams of people who work on spacecraft that actually explore the depths of space, answering our deepest questions and uncovering more and more of space's mysterious and beautiful secrets. One of these people working on such a project and helping the human species to understand more about space is today's presenter, Matt Garrison. Matt Garrison has received a Bachelor's of Science and a Master's in Science in Aerospace Engineering from Penn State University and has worked at NASA Goddard ever since. He began in the thermal engineering branch, working on the James Webb Telescope and the Lunar Reconnaissance Orbiter before becoming the thermal lead for Advanced Topographic Laser Altimeter System. He joined the Systems Engineering Education and Development Program, where he acted as the lead instrument systems engineer on the L. Ralph instrument on the Lucy mission from award through launch. Matt has recently been the payload systems engineer on DAVINCI and the principal engineer of the GSFC Planetary Science Projects Division. He is now working the lead project systems engineer for DAVINCI. And just as a little fun fact, him and his wife have made it to over a third of our national parks, which is just so impressive. So today's presentation is called The Long Tour and the Big Plunge, the Lucy and DAVINCI missions at NASA Goddard. I'll tell you right now that I went down the rabbit hole. I looked into this for about an hour or two last night, and it just seems like such a cool mission. There doesn't really seem like anything to compare it to. Both missions are extremely ambitious, exploring both the asteroid belt and the hellish environment of Venus. I'm very excited about this. I am stoked to hand it off to our presenter, Matt Garrison, who will share his screen now, and we will get started.
All right, Jesse, thank you so much. Can you confirm that you can hear me and see my screen?
Yes, I can hear you and see your screen. Sounds good.
Well, again, thank you all so much for having me here. disappointed I couldn't go there in person, partially because Voyageurs is one of the ones I haven't been to yet. And there's a spot on my banner waiting for a pin. So yeah, I'm going to talk about two of the most recent planetary missions that I've had the pleasure to work on, Lucy and then DAVINCI. So I already gave a quick intro, but just a little more kind of personal stuff. So I'm from State College, Pennsylvania originally. So that is the small town, like right in the dead center of Pennsylvania. I grew up there, really like loved reading, running. I enjoyed school. And State College isn't known for much, but we do have Penn State University in it. And, growing up there, I wasn't necessarily excited about going to the school that was like in my backyard. But my dad worked there, so I got in-state tuition and faculty discount, and that was a huge selling point. But since I've lived there for so long, like my wife and I still have the same season tickets I've had since I was 5. So we go out for football games multiple times a season. So we're really still like tightly tied to that. But since 2005, I've lived down in Maryland, right outside of DC, and worked for the Goddard Space Flight Center. So I mentioned that I did a lot of thermal work originally, making sure that we can keep things cool enough or hot enough in space before I went into my current field. And I said, the thing I worked on that you probably know the most about right now is the James Webb Space Telescope, which we were all keeping our fingers crossed years ago when it launched, and it's just been exceeding everything we'd ever hoped for. So I'm going to it'll be about 30 or 40 minutes talking about Lucy and DAVINCI, and try to leave some time at the end for some questions if you all have any. So starting with Lucy, this is a project that we worked on here for about 5 or 6 years and launched in 2021. So on this animation on the left, just to kind of ground you, the yellow dot here is the sun. The blue dot going around is Earth. And this orange dot slowly going around the perimeter is Jupiter. The Trojan asteroids are a group of asteroids that lead and lag Jupiter, sharing its same orbit. And we want to go out and study these because these are, the main belt asteroids are all in the middle here, and they've been crashing into each other. They've been relatively warm because they're closer into the sun. So these are asteroids that we've never had a chance to study, and they are probably a little better preserved than the ones in the main belt. So the whole Lucy mission was to go launch and study these asteroids by flying by them and taking a bunch of images. So I'll walk through the trajectory that kind of lets this happen. We launched in 2021, and in the first year, we basically just went around the sun once and came back to Earth and did a flyby. So we were able to basically have Earth give us an extra little boost, and that sent us out on a bigger kind of oval orbit back down through here. And this is the phase we're in now before we encountered Earth one more time. So this is going to happen actually this December. And that last one is going to kick us out even faster. So first we're going to pass a main belt asteroid named Donald Johanson, who's the guy who discovered the Lucy fossil. And that'll let us practice what we're going to do so that when we get to these Trojan asteroids, we know what how to operate the spacecraft. So we are going to see in this first pass, we're going to fly by 4 different asteroids. I apologize for the names. These are named after characters from the Iliad, which is the prequel story to the Odyssey. But it means they're really difficult names to pronounce. So we'll start by flying by Euripides and then Polymele. So these are both individual asteroids, and we'll fly by them, taking a bunch of pictures and spectra. And then we get Lucas, and finally we fall down to Orus. So we'll have a chance to see all 4 of these up close before we fall back down towards the sun and get one last kick that sends us out to the lagging swarm of asteroids. And here we'll actually see a binary pair. So these are 2 asteroids called Patroclus and Minucius that orbit each other. And so we'll get to watch the 2 of them as they're orbiting each other. And that's the whole mission. That is a 12-year cruise from the time we launch until we're done with this in order to go tour around all these asteroids. And when that's done, we're just out drifting in space. We will keep kind of looping back around to the sun and back out towards Jupiter over and over. At some point, the spacecraft will die, but we'll have run out of things that we're trying to study at that point. So we needed to build a spacecraft that could do this. And what we came up with is this Lucy spacecraft. So it took us about 500 people when it was all said and done to design, build, and test this. The full thing weighs a little over 3,000 pounds. And it's got a really robust design because when we are close into the sun, things might be running plus 300 degrees Fahrenheit. But when we're further away, it could be minus 250. So it's really cold. We also, when we are out at Jupiter distances, we need solar arrays that are 30 times bigger than we're used to get the same amount of energy. So that's how we end up with these massive solar arrays that are sitting out on either side of this little spacecraft. So for a sense of scale, if you tip this thing on its side, it's about the same size as a 4-story building. This whole thing gets folded up and stored inside a rocket to launch, and then it all comes out once we are in orbit. So here are some pictures of us having put this together. We did a lot of this assembly and testing during COVID. So on the one hand, you know, it was a little like there were some people that were concerned about going out and about during COVID. But on the other hand, anytime you're working with a spacecraft, you're wearing, you know, a full bunny suit, you're wearing 2 layers of masks, you've got facial covers. So, you know, I was probably better protected in work than I was just going to the grocery store. But this is just to give you a sense of scale for this. You know, this little part here in the middle is this big thing sitting behind me right here. So this is just showing everything starting to come together. Here is the particular instrument I worked on called LRALPH. So this is the main way we're studying these asteroids. Is this, you could think of this as taking, instead of like a 3-color image like your phone does, this takes about almost 1,000-color image per for the whole asteroid, and that lets them really figure out like what minerals are there, what the rocks are on the surface, find if there's any variation in chemicals or color. So it's a really interesting thing to have set. And on the right here is me and 2 of my friends. Right at this point, we have finished assembling the whole satellite. It is folded up, and this is kind of the configuration it's going to be in when it goes on the rocket. So I mentioned these solar arrays. They were really interesting. So these open up kind of like Chinese fans. So they're stored up in these little like black triangular panels, and then there's a winch that pulls on this cord and opens them up and tightens them. So these were something that let us get that big of a solar array on a fairly lightweight spacecraft. Opening these up was always an interesting challenge, and it was really, really glad to see when it worked. So we get everything tested. We've built everything, we test it, then we go down to the launch site. So we were launching in Florida. And so once we do all the final checkouts and inspections, we get closed up in this fairing. So this is Lucy, and this is the last we ever got to see it. Once these 2 kind of clamshell pieces come on and get sealed up, the next time that Lucy is going to see any sort of daylight is when it's in space. So here I am in front of the fairing on a cart, and here's with our satellite stored safely up inside. That gets trucked onto the Air Force Base. Actually, it's now the Space Force Base, and lifted up on top of the rocket. So this building is as tall as a rocket, and it has kind of like garage doors that open up sideways so that you can roll this thing out. So it opens up, they lift this on top and attach it to the top of the rocket. And then the rocket rolls out on these train tracks to the launch pad. So this is where you could stand. And this is the view from that stand looking out at our rocket the night before launch. So at this point, everything is set. And we are ready to go for a launch at, I believe it was 2 in the morning. So I did not have to work the launch itself, but what that meant is that at midnight, I got up and I drove to Kennedy Space Center, got on a bus that took me to a viewing area so that at 2 in the morning, I could watch this go up. And it launched perfectly on the first try. Sometimes they have to like pause for weather or anything like that. And it was just, the weather was beautiful. It went up great. So you can see the rocket lighting. And here's kind of a time lapse of looking at this as the rocket ascended and then turned and started going eastward. So that was in 2021. In November of 23, we actually found a surprise. And on that second go around the sun, we found that there was actually going to be an asteroid we were going to pass nearby. So we fired our thrusters and did a little bit of a divert and got to fly by a surprise bonus asteroid named Dinkinesh, but it's small, so we all call it Dinky. And so this is the first picture we got from Lucy of an asteroid outside of the our primary mission. Another cool thing about this is since launch, they've added some new people onto the science team to do some of the data processing. And one of the people they added on who's done some of the processing on Dinky is a guy named Brian May, whose day job is the guitarist for Queen. So he has a PhD in astrophysics, and he's currently on tour in Japan, but he's spending some of his time while he's there looking at data from the Lucy mission for us, which is not something I had ever thought of when I pursued this career. So if you want to keep track of Lucy, there's a website called whereislucy.space that'll take you to this page. I did not refresh this since my last talk, so we're a little bit further on, but this shows similar to those views I saw before. The sun is in the middle, green in this case is Earth, and white is Lucy. And so this gives you an idea of where Lucy is throughout its trajectory or throughout its mission. Gives you a whole bunch of statistics about how long it's been since launch, how far we are to the different asteroids we're going to encounter. It's a really neat website. So if you ever want to get an idea of where Lucy is as it's flying around the sky, this is a really good reference for you. So I want to pivot because that was the most recent mission that we launched with NASA Goddard Space Flight Center for a planetary mission. I now want to talk about the one that we are starting to work on now. So this is called DAVINCI. It's a big acronym, but importantly, we are going to go study Venus. So this is a stargazing event. If you go outside just before sunrise and look to the east, you're going to see a really bright spot before the sun comes up. And that's Venus. So it's called the morning star or the evening star, depending on where it is in orbit. And it's the brightest thing in the sky other than the sun and the moon. So it's always, Venus is closer to the sun than us. So it's either to the east during the morning or to the west in the evening. But it's the brightest spot out there. It's really hard to miss. And we want to go study it. So we've got a really big team working on this. There I am. I apparently need something other than flannel to wear. But the reason we want to study Venus for a few reasons. One is Venus is a lot like Earth. It's about the same size. It's just one planet in closer to the solar system. But its atmosphere is really different. All the climate change that we're dealing with, our atmosphere is still only like 6 or 7, maybe 8% carbon dioxide. Venus's atmosphere is 95% carbon dioxide. So their greenhouse gas is just, way worse than anything we'll ever have to deal with. It's also, the surface is really interesting. There's a lot of evidence of like lava flows in volcanoes, which is something we don't get to see a lot of in other planets. So it's got an interesting surface, it's got an interesting atmosphere, and it's a really good analog to kind of what Earth could have been like. On top of that, I mentioned Venus is really bright. And what that means is that when you've got things like the James Webb Space Telescope, it's going to be easier for James Webb to find Venus-like planets than other planets around other stars. So when we're looking at other stars in the galaxy, we have a good chance of seeing more Venus-like planets. So if we can study our Venus, then we might have a better idea of what's going on with those other Venus-like planets out there. On top of that, Venus hasn't been studied that much. We have years of video and pictures of the Mars surface from all of our different rovers. These are the 4 pictures that humanity has ever taken on the Venus surface, all of which taken by the Russians in the 70s and the early 80s. So these are false color. They're colored based on what we think the color is on the surface, but these are the 4 pictures. You'll also notice they're all pretty flat, nondescript looking areas. That's because the Russians didn't try to land somewhere rocky. They wanted to land somewhere they were guaranteed it was a good flat surface. So they targeted areas that we knew were flat. It ups the chance of them surviving, but it also means that you don't have the most interesting looking land to look at. Excuse me. So we said the Russians have been there. We have some things that have flown by and taken images from above. We want to study what stuff looks like as you descend through the atmosphere. So I mentioned the Russians had a few landers, but the landers got to the surface and then took some measurements and some images, but they didn't really do much on the way down. The missions that are orbiting are doing a really good job with radar mapping, but Venus is covered by these really thick clouds, and so you can't really take pictures through them that well. And then in the 70s, NASA tried sending another set of probes to Venus, and unfortunately, they developed a clog in a little inlet partway down. So they stopped taking good data somewhere around like the 40-kilometer, like 30-ish miles up. And what that means is there is about 75% of the atmosphere in Venus has never really been studied. And that's what we're going to be doing with the DAVINCI probe. I mentioned the terrain being really interesting. So this is a radar map. So this is an elevation map of Venus. The blue are low-lying areas. The red and white are high elevation areas. And this just shows like it's really drastic and dramatic of what it looks like on those surfaces. We're going to go to a place called Alpha Regio. So I'll talk a little bit more about Alpha Regio in a second. So that's where we're going. That's why we're going. But how is the fun part? I'm an engineer. I want to be focusing on how we're actually going to be able to pull this off. So we are going to launch in 2029, and right away, within the first 6 months, we're going to fly by Venus. We're going to we actually have to pass it twice before we can drop our probe. But while we're doing those flybys, we're going to take pictures. We're going to look through the clouds with some special cameras. So we'll study it as however we can those 2 times. But then the 3rd time in 2031 is the really fun part. That's when we drop our probe. And that's where the real heart of the mission is. So our spacecraft is passing overhead. We will kick off this probe flight system, which protects us from the heat when we enter the atmosphere, and then we drop our descent sphere. So this is it's about a 3-foot wide titanium sphere that's full of all of instruments and cameras, so we can study the atmosphere on our way down. I won't go into the details of a lot of these, but VMS and VTLS, these 2 together, these are sniffing the atmosphere and figuring out what the gases are made out of. These are basically the heart of the Curiosity rover. So this is the primary chemistry lab that the Curiosity rover is taking around the Mars surface. VENDI is a camera that's looking through a window at the bottom so that we can get really good images of the surface as we fall through the clouds. And VFOX is a student experiment. There's actually a group of undergrad students at Johns Hopkins University up in Baltimore that are going to be putting this together for us, so that in the end, we'll have something that a bunch of students have worked on that we will, drop into the Venus atmosphere. So we're really taking kind of the payload, all the instruments, the science measurements from the Curiosity rover, and buttoning them up inside of the sphere and sending them skydiving through Venus. So the reason we're doing that is because Venus is a horrible place. Mars it's a little chilly, but it's really not that cold. There's an atmosphere. It's not a lot, but it's not nothing. And so you can take your time roving around, taking careful measurements. Venus isn't that way. When we hit the atmosphere, we're going to slow down at 38 Gs. So basically everything will weigh 38 times more than it does when we're decelerating. So my little lightweight laptop weighs more than 100 pounds at that level. The surface temperature is 900 degrees. That's enough to soften aluminum. Or if you've ever had like a good wood fire pizza oven or pizza, those ovens in the back will maybe get to 900 degrees. So it's really hot. Those clouds I talked about are sulfuric acid. So they are about 3 times harsher than the sulfuric acid that we use to etch steel in industry. And then the atmosphere is so thick that the pressure at the bottom is about 90 times what it is at Earth. So it's the same as going a whole kilometer below the ocean surface, so the bottom of the Arctic Ocean. On top of that, we're trying to land in trying to descend over a really rocky mountainous area. Actually, after talking with the group here, I reached out to the National Park Service, and we found that the best comparison points for it would either be Great Basin National Park, which I got a picture of here, or certain parts of Yosemite. So, picture like you're standing in Yosemite, half domes above you, but it's also, it's overcast with acidic clouds. It's 900 degrees and you're getting crushed by the pressure. So like I said, it's not a fun place. And that's why our way to approach this is to just send this probe screaming down through the atmosphere, take what measurements we can, and then hit the surface. So that's what we're doing. This is to give you an idea of what I call the big plunge. We'll be working on this mission for about a decade, and our primary science mission comes down to 1 hour. So once we enter the atmosphere, we come out of this entry vehicle, and our probe is hanging out under a parachute. And for about 30 minutes, it's going to slowly fall through those upper atmosphere, measuring the chemistry and the temperature and the pressure until we get to about 30 miles up. At that point, we're going to cut the parachute and free fall the rest of the way. At that point, we also start taking pictures down through the clouds. And then once we come out of the clouds, we'll get really clear. And we hit terminal velocity and we free fall into the surface. To give you an idea of how thick that atmosphere is, I mentioned this thing, it's like a 700-pound titanium ball. We are free falling from 30 miles up once we cut that parachute. And we only hit the surface at about 30 miles an hour. So you can think of this much more as like a rock falling in water than something falling through the air. We aren't going to try to land. We say touchdown here, but like we're going to impact the surface. And that means not just do we have to make sure we get all the right measurements at all the right times this whole way down, but we have to be sending that data live to our satellite that's orbiting overhead. So that means, that's a really tight constraint where we only get an hour, and what data we don't get at the end of that hour is just lost. It's something we'll never get back. On top of that, that carrier is going to store all the data and then turn back to Earth and send the data back to the ground, which means those of us who are working on this, we're totally blind. We're not going to start getting any data on this until it's already done. So our spacecraft that we've spent so much time on will be an overheated, maybe broken thing on the Venus surface with a dead battery by the time we have any idea whether it actually worked properly. It's going to be a stressful period. And since it's hands off, I'm not sure whether I actually want to be there to watch the data happening or if I'm just going to take vacation, like go be in the mountains at the time. So that's kind of where we are. Venus is going to be a really interesting target. DAVINCI is going to be a really exciting mission to work on. We are still in the kind of the preliminary design stage of that. We're still figuring out exactly what everything is, what everything has to do. We have to have our plans solidified and NASA have bought off on it by 2025 or 2026. And then at that point, we can start building and testing everything for a launch in 2029. And by 2031, we'll have entered the Venus atmosphere. Now, if you go back to Lucy, which I mentioned was a 12-year-long mission, Lucy, you'll still have 2 years to go by the time the DAVINCI mission is designed, built, tested, launched, and done doing all of its studies. So gives you kind of a clue of the wide range of things we can deal with here. So that was all I really had. And I apologize, I went a little faster than I thought, but that doesn't mean we have time for any questions and answers. So yeah, thank you all for your time on this. This is a really cool job, and I absolutely love getting to work on missions that are a chance to discover new things, and just a chance to like go have interesting talks with people. So I appreciate your time. And Jess, I think it's over to you.
Yeah, well, thank you again so much. That was really interesting. We do have a few questions. And actually, if you could ask teachers out there, if you could use the Q&A box to mention what school you're from and what city you're from, that would be really great, just because we have so many people from all over the country. It's really great to see that you're all tuned in and curious about this stuff. So the first question comes from, I'm going to butcher this name, but let's go for it. It's Miss Lagergren, and they kind of have a two-part question. And it goes, what took us so long to start studying Venus? Meaning, is there a reason why we studied Mars more than Venus?
So when the Apollo program was wrapping up, there were kind of two camps. One was saying, hey, let's go study Mars. The other one was kind of pushing more in the Venus direction. Mars at the time was thought to be a little more hospitable. So they thought, with the idea that the holy grail for this would be finding signs of life, they thought that Mars might be a better option for that. The more we've learned about Mars, the more barren it looks. Frankly, what I'm describing Venus, it's not a very hospitable place either. Although there are some theories that, microbes, small life could exist in the clouds. So when you get to the higher level of the clouds, it's actually fairly Earth-like. There's an area around 35 miles up where it's about room temperature and it's about 1 atmosphere. So there is still some options there that there may be some interesting, some signs of life to discover. But in the end, I think we invested in Mars more because we thought the chances of finding something there were higher. You can tell that the Russians felt differently because the Russians haven't really done any Mars exploration that's really noteworthy, but they were the leader of Venus exploration for the longest time.
Yeah, I seem to remember reading about that. They sent out a few spacecraft, and I forget the collective time that they lasted on there, but I know they were. It didn't last long. They were just crushed by the intense pressure of this.
Yep.
Great. All right, we have another question from Nova, and they ask, would it be possible to collect a sample from the asteroid and bring it back to Earth?
So it is possible. We're not going to be able to do with this. Because if you go back, when you looked at that kind of map I was showing you, we fly by 4 of them and then we come back to Earth. So there's a possibility we could have done that. The problem is we are passing by those asteroids so quickly. It would have been really hard to do that. I mentioned this, there's kind of a line of planetary missions that we've done here. The one before that I didn't talk about is OSIRIS-REx. So you may have seen that in the news over the fall because that one went out to an asteroid called Bennu. orbited the asteroid, grabbed a big sample, and in the fall brought it back to the US. So that came down in the Utah test range in, I think it was October. And they've opened up the capsule and found they brought it, I think it was on the order of a few pounds of asteroid back. So there's actually one little sample of it in the Smithsonian that I need to go check out. The Air and Space Museum is closed, so it's actually right next to the Hope Diamond in the Natural History Museum. And so I got to work on that a little bit, but I'd love to go see something I had hand in right next to the Hope Diamond. Like, that sounds really cool. But that was a whole dedicated mission just to grab one sample of an asteroid and bring it home. So it would have been really hard for us to do it on this.
Right. So it's possible, but for this mission, it won't be happening. Understandable. I have two questions for you. One that I missed before. I'll just ask them both at the same time. One of them is from Gabby. They want a reminder of when DAVINCI is being launched. And then the other question from Declan is, which planet will we study next?
Ooh, so there are some fun ones out there. Okay, so DAVINCI's aiming to launch in 2029. But there are some really cool missions going right now. There is Europa Clipper is hopefully going to launch this fall. That is a big mission. It's going to be like a Cassini-sized thing that's going to fly out and study Europa, which is one of the moons of, I really hope it's Jupiter. Jupiter and Saturn's moons, there are a whole lot of them, and I always mix them up. But Europa is one of these or one of these moons around one of those gas giants that they think there's a possibility of it having at least an atmosphere or a environment that could support life. So that's going to launch this fall. There's also Dragonfly, which is an awesome project. It's actually being built by the Johns Hopkins Applied Physics Lab, which is about 10 miles up the road from me. And this is a nuclear-powered quadcopter drone that's going to fly around the moon Titan. That's a moon of Saturn. So Titan has an atmosphere. It's about 1.5 times as thick as ours, and that turns out it means you can fly. So it's going to act like a lander. It'll go land. It'll take measurements, and then they'll tell it to go up and fly, a mile that way. And it all has to do it robotically on its own. It has to be self-navigating because it's so far away. But it'll go fly there, land, take more data, and they're going to slowly march it across the surface of Titan to go study this area that has some craters and some dunes. Titan's really cool because, well, one, it's very cool. It is 200 degrees below below zero. And it turns out that means that it has something that looks like the water cycle on Earth, but it's all methane. But it rains methane, there are rivers, there are lakes, there are puddles. So you can look at the weather and it looks kind of like Earth weather. It's just way, way colder and it's all hydrocarbons. So those are probably two of the bigger, more interesting ones that are coming up soon. Like I said, Europa Clipper is going to launch this fall. Dragonfly is just starting to get built now. On top of that, we also have the Artemis program where we're hoping to send astronauts back to the moon. I think they announced a delay, so it's going to be like 2025. So Artemis 1 was last year, where they sent the spacecraft out around the moon and back without humans in it. So that was fully robotic, just to make sure that everyone would that the thing would survive. They're going to basically repeat that now with humans in Artemis 2. And then Artemis 3, they'll actually send them back to the lunar surface.
Wow.
And then you'll also see there's some commercial stuff going on. So there are a handful of independent companies that are building lunar landers. So what NASA's doing is saying, hey, we will pay you to go take our cameras or our radios or whatever special instruments we want to the lunar surface and operate them for them. And that means you've got small companies that are, may only be 50 or 100 people who are investing their own time and their own money into building stuff to go to the moon. The first one was in the news early January. Unfortunately, it didn't make it. They had a problem where they had a fuel leak, and they basically lost all of their fuel within a few hours of coming off the rocket. So they weren't able to land, but there's another one coming up, I think, in a few weeks. So it's something to keep an eye out on.
Wow. Yeah, lots of cool stuff on the horizon. And I want to say, I don't blame you for forgetting which moon belongs to which planet, because Jupiter, I think, does have like 90 something moons. Saturn also has a ton. It's so easy to mix them up.
Yeah.
So one of them you did, we have another question. One of them you did touch on a little bit, but maybe I'll ask you again in case there is more to it. And that question is, are there any human manned missions now? Is there anything else besides the Artemis project that you were explaining?
Yeah, so we talked about Artemis, but there's still the International Space Station. So there are usually, I think it's like 6-ish people living and working the space station any given time. I think we broke our record as humanity a few months ago, where we had the most ever humans in space at once, because there's the International Space Station, the Chinese had a space station, and there was also a suborbital thing where it goes into space, but it's not fast enough to go all the way around. So there was a little period of time where we had 20 some people in space at once. So yeah, there's still stuff like that going on. It's an interesting time to be doing all this. You've got people running all around everywhere. You've got independent companies trying things, and then you've got the big government stuff working.
Absolutely. Fantastic. Claire asks, what will you do with the information that Lucy brings back?
So one of the way those asteroids have kind of clustered around in Jupiter, they think that makes them really preserved, well-preserved relics of the early solar system. And so by studying what they're made out of, hopefully the scientists can get a better idea of how the planets formed, what was floating around the sun originally when all the planets kind of came together. So it's a way to try to learn that. The ones we're studying out there are so far away from Earth. These are not the ones that we're ever worried about them coming to impact Earth or anything like that. So these aren't things that we're worried about, like, a doomsday event. These are really just help us understand the solar system, how we got here, and maybe how the other solar systems we're seeing through our space telescopes come together.
Fantastic. James has a good question. He says, will you ever go to space? I'm guessing you, Matt Garrison, will you go to space?
So I applied to be in the astronaut corps once. I received the form letter that says, thank you for your application, and nothing else. It is the astronaut corps is a really interesting group. So honestly, even if I was given the option right now, I probably wouldn't. And the reason why is because most of the time when you're going to space now, you're going to the space station and you're going to live there for 6 months. And that doesn't seem like the kind of experience that I want to spend half a year doing. It was different when it was the shuttle, because the shuttle would go up for a few days at a time, maybe a week. And like, I could rough it in a cramped quarters with a whole bunch of people for a week. I don't know if I want to do that for like 6 months or half a year. So these days I'm okay being on the ground.
Yeah, that's a good point. The novelty might wear off after a few days of being trapped in a small container with the same people.
Yeah, but the view from up there does look awesome.
Oh my gosh, it'd probably be life-changing. Yeah, absolutely. AWLC 7th and 8th graders ask, why is there a delay in the data from DAVINCI when it's going down?
Oh, so that's actually really good. So as the probe is falling through the atmosphere, we have a relay satellite that's going overhead. So that satellite's pointing its antenna at the probe. So the probe can send all of its data up, and it's going to store on that spacecraft. And once the probes hit the surface, the spacecraft will turn back to Earth and then send the data. So
Gotcha.
it's not like It's not like one of these things that's way out in the solar system and it takes minutes for the data to get there just because of the speed of light. This is just a matter of, we want the satellite tracking the probe the whole time, and then we'll worry about sending the data back to the Earth.
Right. Fantastic. We have, actually, we got two more questions. One from the same school that just asked, and they asked, if the space station, we have a student wondering if the space station will not continue to be used or funded under NASA.
So there has been talk for a few years about, the space station's getting old. It takes more cost to maintain. There's also a few of those private companies who are talking about putting up their own space stations. So at some point, the space station will die and we'll have to deorbit it. When big things are in orbit and they're going to die, we want to make sure we control them coming back into the atmosphere, because they'll burn up, but maybe they won't all burn up. Maybe there will be big hunks of metal that continue to fall. And we want to make sure we're steering those to like unpopulated areas in the ocean so that we don't go drop a big slab of metal on, I don't know, New Jersey.
Good idea.
Yeah. So we will at some point decide that we need to deorbit the space station. We have the same conversations with Hubble. I mean, Hubble is 30 years old. I think older actually at this point.
Wow.
And at some point it's going to die and we're going to have to bring it back into the atmosphere. So yeah, it will have to happen. One of the things we've learned a whole lot building that. And part of the moon's exploration program is we're building a smaller space station that will go around the moon called Lunar Gateway. So, even when the International Space Station dies, what we've learned and developed in that we'll be carrying forward to the moon.
Great. Yeah, that's the great thing with this technology. It's not just for this one project. You can use it for future ones. Kind of like stepping stones. I love this next question. Nova's asked, what mission would you do if you had unlimited funding?
Oh,
that's a good one.
Yeah. So James Webb has been great. It's done a lot of good work, but there is another telescope that is in the works. And this is like 2040, so way off.
Yeah.
Called the Habitable Worlds Observatory. And the idea for that one is it's going to be even bigger than James Webb, and it should be able to actually take pictures of planets around other stars. So,
cool.
To be able to build the thing that gets to actually get resolved images of other planets around other star systems would be amazing.
Wow. I would love to see that. The idea of exoplanets really fascinates me.
Yeah.
And I heard something, maybe you can confirm if this is true or not. I think I remember hearing that most stars have at least one exoplanet, or and they could have more than that too. So when you're looking up at all the stars and you think about all the planets of our solar system, maybe each one of those stars have some semblance of that as well.
So the coolest thing I can ever, if you ever want to really scratch your head on something, go look up a picture called the Hubble Extreme Deep Field. So this is they took Hubble and they pointed it at what they thought was a dark spot in the sky for weeks. And this is an area smaller than the full moon in terms of how much sky it takes up. And they got thousands of very distant galaxies. And each of those galaxies, thanks for whoever pulled that up. Each of those galaxies is like the Milky Way, has millions of stars in it. And what we've learned from studying stuff in the Milky Way is that most of those stars probably have planets. So unfortunately, we've got a really bad data set. We have a confirmed one that has life on it. But other than that, the list of planets that should be around other stars in other galaxies is such a crazy big number that it really kind of makes you scratch your head.
There's nothing seems unfathomable. I love that picture yeah, each of those points of light are not stars, they're galaxies that have hundreds of billions of stars in it, and then
Yeah.
each of those stars probably have planets around it. It unfolds deeper and deeper. It's just hard to even begin to comprehend.
Yeah.
Absolutely. I actually, there's no other questions. I have one though.
Sure.
I was wondering, so I know one of the big issues with Venus is that the pressure is just so intense. So has there been a development, a new kind of technology that has been improved since when the Russians sent it out versus now, that now it can withstand that extreme pressure?
So actually, what killed the Russians wasn't the pressure, it was the temperature. So when you think
Oh,
about
okay.
like your computer, your phone, as the electronics are running, they have to put out some heat. And normally, your phone takes care of that just by being a little bit warmer than the air around it. The problem is that Venus is so hot, like you need to insulate yourself from that heat, which means the heat inside has nowhere to go. It eventually just warms up and overheats itself. So there's not a lot you can do about that. In terms of designing for the pressure, though, like you said, this is kind of the equivalent of the bottom of the Arctic Ocean. So we did what anyone else would do, and we went to talk to the Navy. So the Navy and the Woods Hole Oceanographic Institute are helping us design something that can handle that, because their subs do that all the time. Like, this isn't a new challenge for them. They're fine with it. So
absolutely. Yeah, I love that's the thing I love about these projects is you have a question and you have a goal, and then you say, what things do we have to do in order to accomplish this seemingly impossible task? And you reach out to other experts and other branches of science. It's all very interdisciplinary.
yeah.
Thank you. And actually, we do have a new question that's popped up from Claire. Claire asks, are there a lot of other habitable planets?
So this goes back to the whole, unfortunately, like, we know of one, and that's Earth. So we try to, that there are whole groups of scientists who try to figure out what it takes to be habitable and try to find other places it could be like that. So there are a handful of places in the solar system where they think the conditions for life might be there, but it's really hard to tell. And with what we currently have, we really can't look at planets around other stars to determine that. So unfortunately, it's really hard to tell.
Right. Yeah, it's a good point. We know that. Yeah, go ahead.
Oh no, I'd say I do want to, before people drop off, make sure that the pitch for, I know that there are people dialing into this from different spots in the country. If you are anywhere near the eclipse track on Monday, April 8th, go get yourself those fancy glasses and go outside. And if you are in an area where you can get to the path of totality, where you're going to get the full, like the sun's fully blocked out, it is worth the crowds and the traffic to go there. I did that a little bit ago, or for the last one, which is 4 or 5 years ago, probably. And it was an amazing experience. I was not expecting it to be as cool and mind-bending as it was. So
yeah, I haven't seen one either, but every person I know that's seen a total annular eclipse describes it as just indescribable. The sky goes black, the animals respond to it. It's a very surreal kind of experience.
Yes.
Fantastic. Well, thank you so much. We're going to wrap it up, but for those of you on the call, if you have any other questions, please feel free to email us at education@voyageurs.org. It's the email that we've already been communicating through. And if you're in the States, please keep an eye on our schedule on our website. We have lots of we got a few more programs going on with telescopes involved. I'll be there in Duluth tomorrow. There's another thing happening at the Wood Lake Nature Center near the Twin Cities. And then on Saturday, we have another telescope and skiing event up here near the park. Yeah, so thank you all so much. Thank you, Matt, for joining us and for sharing your expertise. It's truly fascinating stuff. And we appreciate everyone for tuning in to this call. Matt, do you have anything else you'd like to add?
Not at all. Just thank you all for having me. If you like space, if you find this stuff interesting, NASA and all the companies involved in this, they're always looking for people who are interested and passionate. You can do it the engineering route. You can do it the finance route. We have technicians. I work with a whole shop of people who are seamstresses on the weekend, but during the days they make those space blankets. So, and anyone who's got interest, there's work for everyone to do in these, and it's a great place to be.
Absolutely. It takes a very diverse team to accomplish such a goal. We also want to appreciate our ASL interpreters. Thank you so much. And our live captioner for increasing the accessibility. We really appreciate every single person that has joined this call. All right. Thank you again. We will be signing off now. And again, shoot us an email if you have any questions at all.
All right. Thanks, everyone.
Thank you so much.